This video is on section 2.3, just solving linear equations. This is a continuation of what we did in section 2.2, and we're going to just work on some more complicated equations. So the first kind of equation I wanted to look at is when you have distribution. So if you have something like this, and you need to solve for x. So here we have this 5x minus 15 in parentheses, and before we can start solving for x, we have to take care of the parentheses. So we have to distribute a -1 through. So that's going to be negative 5x plus 15 equals 10x. So now I'm going to add the 5x to both sides so that now I have 15 equals 15x. Dividing both sides by 15 gives me 1 equals x, which is the same as if I had x equals 1. Another example of the same sort of problem is this. And so the first thing I'm going to do before I start working with anything else is distribute the -4 through the parentheses. So I'm going to get -4y. -4 times -6 would be plus 24 plus 4 equals -8. Combine the like terms. And then since I have the y on this side, I'm going to subtract the 28 over to the other side. So -4y equals -36. I'll divide both sides by -4, get y equals +9. So that is how you solve an equation where there's distribution. The next topic is what to do when you have a linear equation with fractions. So if I had something like 4/3 x minus 2 equals 2x plus 1/4. Now I could start subtracting x's to one side and numbers to the other side. But I would have to do a lot of addition and subtraction of fractions if I was going to do that. So the easiest thing to do would be to clear the fraction, and I can do that by multiplying both sides by the GCD, the greatest common denominator of all the fractions. So in this case we have a 3 in the denominator here and a 4 in the denominator here. So the greatest common denominator is going to be 12. It's the smallest number that is divisible by 3 and 4. So I'm going to multiply 12 through here. And remember that this is a 12 over 1. It's not a 12 over 12. So don't multiply the denominators by 12. So here, I'm multiplying 12 by 4/3. Well, that is going to give me 16. So I will have 16x minus 2 times 12 is 24. And then over here I'm going to have 24x. And then 12 times 1/4, that's going to be 12 over 4. which reduces to 3. So now I'm going to get all the numbers on one side, or all the constants on one side and all of the variables on the other side. So I will subtract that 24x over here, which is going to give me negative 8x minus 24 equals 3. I'm going to add 24 to the other side, or to both sides anyway. So negative 8x equals 27. So I'm going to divide both sides by negative 8. X is going to equal negative 27 over 8. And that can't reduce anymore. So here's another example where I'm going to want to clear the fraction by multiplying by the GCD before I solve for x. So the GCD of 1/2 and 1/5 is going to be 10. 'Cause 2 and 5 are both primes, so I'm just going to multiply them to find the GCD. Okay, so I'm going to multiply both sides of the equation by 10. So that's going to give me, if I just multiply straight across this time, I'd get 10 over 2x plus 40. And here I'm going to get 10 over 5 x minus 20. So now I'm going to reduce these. That's going to be 5x plus 40 equals 2x minus 20. Then I'm going to solve for x. So now I'm finally going to get x equals negative 20. Now for our last example in this video, I'm going to do a linear equation that has decimals. And it's a very similar idea to fractions. You want to get rid of all of the decimals so that you don't have to add and subtract and multiply with decimals. I think I will use a different variable. So here I have a linear equation that has lots of decimals, and I gave them all the same amount of decimal places, so that makes my job a little bit easier. But I need to clear the decimal, and there's two ways that you can think about this. The first way is to think, well, what do I need to multiply 0.15 by to get a whole number? That would be 100, because I need to move it over 2 decimal places. So I'm going to multiply both sides by 100. So then 100 times 0.15 gives me 15. And then 100 times 0.09, it gives me 9. And then this would be 136. If you're having a hard time remembering what to multiply by, you can also just think of moving the decimal place over 2 decimal places in both of these problems. Just remember to move the same amount of decimal places for everything. So then it's just a normal linear equation. I distribute the 15 here. Minus 6 times 15, which is 90. Oh. I copied down the problem wrong. So now I'm going to isolate m. So I have 6m minus 90 equals negative 138. So I'm adding 90 to both sides. And that gives me 6m equals negative 48. Dividing both sides by 6, that's m equals negative 8. So that is a linear equation with decimals. Just remember to move the decimal place so that you get a whole number, or multiply by the right power of 10 to get a whole number. And that concludes section 2.3.